Today we're going to start looking at complex numbers. This is kind of a bigger section, so we're going to split these notes up over 2 days. The first part we're going to be looking at today is stuff with square roots. And you know the square root symbol from previous years looks like this. Another name you might see along with square roots, if you're talking about other types of roots, is radicals. Radicals is another term for a root. Whenever you have a square root of a number, if there are smaller factors that multiply in, you can break the radical up into separate radicals being multiplied each other. So if there's two numbers that multiply to your number, you can split them up into separate radicals. Let's look at an example problem. Let's say you had square root of 12 and you want to simplify that down. Well, what you can do is think of numbers that multiply into 12. One example would be 4 and 3. 4 times 3 is a number that multiplies to be 12. So what this says is we can now split these into separate radicals as square root of 4 times square root of 3. And then if you have any perfect squares, you can simplify those to the actual number. Now, square root of 3 doesn't simplify, but square root of 4 certainly does. Square root of 4 we know is 2. So another way of writing square root of 12 would be 2 square roots of 3. And that would be your simplified answer. Likewise, we can also use this to combine any radicals. So let's say you had square root of 2 times square root of 8. Well, you can bunch those together as in one square root as square root of 2 times 8. Well, we know 2 times 8 is square root of 16. If it happens to be a perfect square like this one, now we know the answer would simplify down to 4. So the answer to that one would be 4. All right. Now, when you're doing radicals or roots, square roots, whenever you simplify a square root expression, do not have radicals or square roots in the denominator. Add any number remaining under the square root has no perfect square other than 1. So what this is saying, anytime we're doing fractions, you don't want to leave any type of square root or radical sign in the denominator. So with this next part, if you have a fraction, you can break it up as a square root of the top over the square root of the bottom, but we do not want to leave a radical in the denominator here. Let's look at some examples with this. So let's say we have square root of 3/4, and we want to simplify that one. Well, what it says over here is we can rewrite this as square root of the top number in the numerator over square root of the bottom number in the denominator. Then you want to check, can you simplify either of those? Well, square root of 3 does not simplify, but we know square root of 4 does. So we can now write this as square root of 3 over 2. We no longer have a radical in the denominator, and we simplified it. Let's look at one a little bit harder. Let's say you have this one, square root of 5/3. Square root of 5/3. Well, just like we did on the last problem, you can rewrite that as square root of 5 over square root of 3. The problem with this one, though, square root of 3 in the denominator doesn't simplify nicely like the last problem. Well, what you do in these types of problems, if that happens, to get rid of the radical in the denominator, is you multiply by that same radical. So we're going to multiply by square root of 3. However, you can't just multiply the bottom and not also multiply by the top. So what we're also going to do is multiply the top by that same radical. So we're going to multiply by square root of 3 over square root of 3. And that's okay to do, because square root of 3 over square root of 3 is 1. And you can multiply anything by 1 and it remains the same. So we're not going to change the value, we're just going to change the appearance of what this is. So if we multiply both of these now, we get on top square root of 15. On bottom, square root of 3 times square root of 3 is square root of 9. Now that turns into a perfect square that we can simplify as square root of 9 is 3. And now that becomes a simplified radical. So anytime you have a radical in the denominator that you can't be simplified, multiply both the bottom and top, the numerator and denominator, by that radical. All right, let's try some of these problems out. Now, when you're doing these, they become a lot easier if you know some of these numbers that we're looking for, some of these perfect square numbers. Okay, and in this chart you can see some of those perfect squares. That's anytime you multiply the same number by the same number. So 1 obviously is 1. That's not one we're going to really use to simplify, but like 2 times 2 gives us 4. 4 is a perfect square. 3 times 3, or 3 squared, is 9. These numbers, 4, 9, 16, 25, 36, 49, whenever you multiply the same number by the same number, those are the ones you want to try to keep in mind, because when you put any of those under the square root sign, such as 49, they simplify nicely. So those are the ones you want to keep in mind. It might be a good idea just to write some of these down at the top of your note sheet so you kind of have them as you're going through. So these numbers, 4, 9, 16, 25, if you jot those down, those are nice ones to have somewhere on your note sheet so you can always refer back to them later. All right, let's try the first one out here. They want us to simplify the radical square root of 50. Now, there's a couple ways you can do this. You kind of pick the best way that you like and go with it. One way is to look for a perfect square that goes into square root of 50. So if we look over on our list, look for a number that would divide into that. Does 4 divide into square root of 50? Nope. Not nicely anyway. It give a decimal number. Does 9 divide into 50? No. 16? No. 25? Yes. 25 goes into 50 2 times. So another way we can write square root of 50 is square root of 25. And 25 times 2 is 50, so square root of 25 times square root of 2. Now you simplify the perfect square number to get the answer. If you simplify square root of 25, you get 5. And square root of 2 does not simplify, so we leave that under the radical sign, and there's the simplified answer. 5 square roots of 2 is the same as square root of 50. If you want to check just to make sure that it does, you could go on a calculator and try it out. So if you type in square root 50, it's about 7.07. You type in 5 square roots of 2, it should be the same value. 7.07. You get the same number. So the value hasn't changed, just the appearance has. Now, that's one way you can do it. If you like that way, it works great. You got to kind of have to know those perfect square numbers, but it works pretty good. Another way some people like to do it is to take the number under the square root and look for other numbers that would go into that. For example, if we start with square root of 50, what are some other numbers? It doesn't have to be perfect squares, just anything. One that really comes to mind quick for a lot of people is 10 and 5. 10 and 5 multiplied to 50. Now, do any of those break down farther? Square root of 5 does not. That's what we call a number that doesn't go up, down any further. That's a prime number. But 10 does. 10 is not a prime number. 10 still breaks down into square root of 2 times square root of 5. So these numbers that remain, we can't break any of these down now anymore. These are all prime numbers. Here's the numbers that are left when we've broken this down. Anytime you end up with a pair, such as square root of 5 and square root of 5, that will simplify to equal just the number underneath. So here's another way you can think of this. Square root of 50 is the same as square root of 5 times another square root of 5 times square root of 2. If we multiply these two together, this pair, square root of 5 times square root of 5, that would just equal square root of 25, which would equal 5. So you also get 5 square roots of 2 that way. So that's another way if that you can do these as well. All right, let's try another one. 45. Now we're trying to think, what are some perfect squares that go into 45? I'll go down the list. Does 4 go into 45? No, it would have to be even for 4 to go in it. Does 9 go into 45? Yeah, I believe 9 does. So 9 times 5 is 45. Which of these is the perfect square? This one. So square root of 9 is the same as 3 square roots of 5, and that is our answer. So square root of 45 is the same as 3 square root of 5. All right, for tomorrow, why don't you try these ones on your own? See if you can do C and D on your own, and we'll check those tomorrow and see what you get. Let's move on to a few that maybe are a little bit tougher here. Let's look at E. This one starts putting numbers and variables. Well, you're going to do the same thing on these types of problems. Look at breaking them down. Now, 25 is one of our perfect square numbers. Square root of 25, we know, is 5. So square root of 25 by itself will be 5. What we have to figure out is what is the square root of x squared? Well, square root of x squared means you have x squared means you have 2 x's under the square root. That would be the same as square root of x times square root of x. And anytime you got the same thing like that being multiplied, that's the same as square root of x being squared. And we know anytime you square something and anytime you take the square root, those are opposites of each other. They cancel out. So the only thing left is x. So square root of x squared would equal x. Okay. So really what it means when you're taking a square root is kind of like there's a 2 there. Anytime you're doing square root, it's like a 2. So if you just divide 2 by 2, 2 divided by 2 means you end up with x to the first power. You can use that little trick on any power. So if you have like 4 here, 4 divided by 2 is going to equal 2. So how many pairs of y squareds do we have? 2. So the answer would be 5xy squared. And that's your solution. Let's try another one. Let's look at F. This one wants us to simplify this one. Now, anytime you got a fraction problem, look first to see does your answer or does your fraction simplify it at all. On this one, we got x squared over x. So if we have x squared, that means there's 2 x's being multiplied on top and 1 on bottom. Can we simplify this at all? Yes, we can. X divided by x, that cancels out. Now we don't even have a fraction anymore. All we have is left is square root of x. And unfortunately, we can't simplify that anymore. And that's the answer. So if you can simplify fractions before you do the radical, that's the way to go about doing those problems. All right, let's look at a few more. On the next page, we want to simplify this fraction, square root of 11 over square root of 49. Just like we talked about before, split that up into the square root of the numerator over square root of the denominator. See if you can simplify. This one happens to work out nice. On bottom, we know square root of 49 is one of our perfect squares. That's 7. We no longer have a radical in the denominator, and our numerator doesn't simplify anymore. That's the solution. All right, let's look at H. Square root of 32 over 81. Why don't you try this one out for tomorrow? See if you can do H for tomorrow, and we'll check that one. Let's look at the last one here, I. On I, this one, we kind of got some variables and numbers, but again, see if you can simplify first. And if you look at this one, 8 happens to go into 32, so we can simplify this one as square root. 8 goes in there 4 times, 4x. Now you want to simplify any farther. Can we simplify either one of those? Well, 4 is one of our perfect square numbers. So we know square root of 4 is 2. Okay, but we still have this x left in the radical sign. Does that simplify out of the radical? Nope. It doesn't have any exponent, so we can't take that out unless it has another friend to come out with it. So this one answer would be 2 square root of x. All right, tomorrow we'll keep going and look at some other properties of square roots. And then the next day we're going to look at something called imaginary numbers.